In this video, I'm going to be assembling and testing this 2.5-inch IDE SSD that I've designed for use in any machine that utilizes a 2.5-inch IDE hard disk, or even a 3.5-inch IDE hard disk with the necessary adapter. Now, for those of you who watch my channel for some time, you might remember that I recently made a video of assembling another IDE SSD that I had designed. However, that one was designed for use in machines that utilize the 1.8-inch ZIF IDE form factor, such as the first generation MacBook Air, Sony Vaio UX UM PCs, iPods, Zunes, or what have you. Now, for this design, I've taken that design and modified it slightly into a 2.5-inch IDE form factor instead. Now, with that said, I designed it for use with basically the exact same components, the passive components, and of course I designed it around the Silicon Motion SM2236 controller, just like I did with that initial drive. Now, I designed this for use with 4 NAND chips, up to 4 NAND chips. You can use any NAND chips that are compatible with the SM2236 controller with it. And yeah, in this video, I'm just going to be assembling and testing this drive, as I said. Now, before we get started, I want to give a huge thanks to PCBWay, who actually sponsored this project and provided the PCBs that I'm using in this video. So, you can see there's quite a few more where that came from. You can see I have quite a few here. There are about 100 boards in here, I believe. So, I do have quite a few that I can assemble over a period of time. Now, PCBWay, I've actually been using them for quite a few years for various different PCB projects that I've had. But in addition to PCBs, they also do 3D printing, CNC machining, sheet metal fabrication, as well as injection molding if you ever need any of those services. And of course, they do offer PCB SMD assembly, but I opted not to go for that because, well, I have the capabilities, although a little tedious, to assemble the boards myself. So with that said, let's go ahead and get started with the project here. I've got all the passive components here, which I purchased from Mouser. You can see they're in here. There's quite a few, as you can see there. Of course, I've got the voltage regulators, a bunch of resistors and capacitors, and stuff like that. So with that said, I'm going to do this assembly in basically 3 steps. The first step is I'm going to tin and install, or tin all the pads on the board and install all the passive components, such as the resistors, capacitors, and what have you. The next thing I'm going to do is install all the BGAs, such as the 4 NAND chips here, as well as the SM2236 controller you can see I have right here. And then the last step is I'm going to install the pin header here, which goes on both sides of the board. You can see it just kind of, the board is kind of sandwiched in between the pins of the header here, which is the most cost-effective way to install a header like this, so that way you don't have to have any that have like right angles or what have you. And then I've also got another 4-pin section of header here to use as the master, slave, and cable select jumper, which of course will install both of those at the same time. So with that, I'm going to go ahead and get the camera and the tripod here, and we'll begin the process of tinning all the pads on the board and then installing the passive components. Alright, so as you can see, I've gotten the board all prepared to start tinning the pads here. So in order to do that, I'm just going to use my soldering iron. So the first thing we need to do, of course, is just apply some fresh flux to all the pads that we're going to be tinning. Of course, I'm not going to tin all the pads because stuff like the BGAs and stuff and these pins up here should not be tinned before soldering. So with that, I'm going to go ahead and start applying some flux to the pads like so. And now with that flux applied, I'll just go ahead and get my soldering iron warming up here. And then once that's done, we can go ahead and start just tinning all the pads with the soldering iron. So in order to tin the pads, all we need to do is take the soldering iron, put some solder on the tip of it here, a good bit on there, and just run it over all the pads. I always like to go in a circular motion, as that ensures that there's an even coat on all the pads, which of course is exactly what you want. Now, as you can see, some pads did not tin quite properly just yet, and I found that some of the ground pads on the smaller components, like the 0402 capacitors and stuff like that, they just don't attach to the solder properly at first. And I found that if you just heat it a little bit with hot air at the same time you're tinning, that will rectify that issue. So I'm going to go ahead and turn on the hot air here, and then I'll just use that to heat as I tin those stubborn pads. Alright, so now that all the pads have been tinned, now I'm just going to go through and install all the components onto the board in order, in just the order basically that I have the parts in the box. So that way I can just go through them one by one, find out how many I need, which spots they go on the board, and then just solder them on with hot air. So I'm going to go ahead and open the bill of materials here, which I have open on the computer. And then I can just go through and I'll know exactly where each component is supposed to go. So with that, I'm just going to go through and install all the components on this side of the board. Then I'll flip it over and install the components on the back side of the board. Basically just repeat this exact same process, and then we'll move on to the step of installing the BGAs. Basically, the way I'm going to do this is I'm just going to put all the components that I'm going to install in this little tray right here, and then I can use the tweezers to just align them into position and solder them on with the hot air. Alright, and simple as that, there's the first set of components installed. So now I'm just going to repeat that process for all the rest of the components until we populate this entire top side of the board. Alright, so that's all the components on this side of the board. So now we'll just go ahead and flip it over, and we can perform the same thing to the other side of the board. And I'm going to do this LED last. As you can see, I left that out because that is very heat sensitive, and I want to put it over the preheater before I solder this on, so that way I can use a lower temperature on the hot air. Alright, so as you can see, the board has been flipped over, so now we'll just do the same thing we did on the other side and tin the pads and then solder the components onto the pads. Alright, so that's pretty much all the components installed, and the last component I need to install is this component right here, either R25 or R13. And basically, just like on my last design, the 1.8-inch design, I have an optional resistor here you can set to either select 3.3 volt IO NAND or 1.8 volt IO NAND. And in this case I'm going to be using 1.8 volt NAND, so I will be setting R25 on top. If you're using 3.3 volt, you just have to set this bottom resistor and leave this one blank, and vice versa. So since I'm going to be using 1.8, like I said, I'll populate the upper resistor there, and that will send the 3.3 volts from the regulator on the other side through this regulator, which will regulate it down to 1.8 volts. And then the bottom just passes through the 3.3 volts straight to the NAND. So with that, I'm going to go ahead and install this. Alright, so there's that resistor installed, set to 1.8 volt NAND. So with that complete, the next thing I'm going to do, like I said, is get the BGA soldered on. So in order to do that, I'm going to go ahead and get the board in the board preheater, or on the small board preheater, and then we'll use the hot air just to simply solder all those chips on. Alright, so before I start installing the BGA chips onto the board, the first thing I forgot I need to do is I need to reball one of these SM2236 chips here. Now, as you can see, the chip does come with solder balls pre-applied, but if you go ahead and take a close look at it, you can see that the quality of those solder balls on there are not very good. You can see there's 2 or 3 missing on that edge there, and with it like that, this chip will not make proper contact with those pads on the board. So unfortunately, most of the chips that I ended up getting this time were like this and are like this, so I will just have to reball these chips, and especially this one, before I install them onto a board. So in order to do that, the first thing we need to do is, of course, remove all the residual solder. So I'm going to apply some flux to the chip just like so, and then we'll just use the soldering iron to remove most of it, and then the solder wick to remove the rest of the solder. And then once all the solder is removed, we are now ready to begin the process of reballing the chip itself. So with that, I'm going to go ahead and start removing the solder. Put a good chunk of solder on there. I'm just going to hold the chip with some tweezers so it doesn't move around on me. And now with that done, we can just go ahead and take our solder wick and remove all of the residual solder. And luckily these chips are very small, so it makes this process pretty quick. And I can actually use solder paste to reball this one, rather than actually using discrete solder balls, which is helpful. Alright, and as you can see there, all the residual solder has been removed. So now I just need to clean that old flux off the chip, and I'll get it aligned on this stencil. As you can see, this stencil does have the correct footprint for this chip, although it is labeled SM2258XT and SM2246XT, which are actually SATA NAND controllers, but the footprint is exactly the same as the SM2236. So I'm going to go ahead and get that chip cleaned, get the stencil prepared with the chip on it, and then we'll begin the process of reballing it. Alright, so as you can see here, I have the chip prepared to be reballed here. So as you can see, I do have it aligned in the stencil appropriately. I've got it just taped to the back with Kapton tape, as you can see right there. So in order to reball this, like I said, I'm going to be using solder paste this time. Normally when I reball larger chips, I choose to use discrete solder balls because it makes it a lot easier that way. But with such a small chip like this, we can just use solder paste. So that comes in a syringe like this, so we just have to squirt some out on the chip. Don't need a whole ton. And then I found that with these chips, it actually helps to add a little bit more flux to the solder paste. And the reason for that is, well, solder paste itself is just little tiny pieces of solder in an emulsion of flux. So adding a little bit more flux will thin it out a little bit and make it flow better into the holes. I found that this particular solder paste is just a little too thick for my liking for these small chips. So with that flux added, we're just gonna go ahead and mix it in, just like so. And you just want to make sure it's evenly in all the holes, just like that. So that looks about good. And then we just take the tool and clean all the excess solder paste off, so that way it doesn't turn into one big blob and get in all the holes and bridge everything. And I just do that by kind of wiping it off with the tool, and then wiping the tool itself off with a paper towel. And that usually will get most of this excess solder paste off. Alright, and that looks to be about good right there. It doesn't have to be 100% perfect, but as long as most of it's off, it will work just fine. So now I'm going to turn my hot air on to about 300 degrees Celsius, and then we'll just use that to melt the solder paste into the holes and onto the pads. And I'm also going to use a pair of angled tweezers like this just to hold the stencil down tightly on top of the chip. That way I can be sure that the solder paste does not bridge underneath the stencil. So go ahead and hold that down and simply start heating. It's going to be a little hard to see this because I got to have the hot air pretty close to it to get the solder to melt properly, but I will show it to you once it is complete. Alright, so as you can see there, the solder paste has turned into what look to be uniform solder balls. So once it cools down just a tiny bit, like it pretty much already has, I'm going to go ahead and remove it from the bottom of the stencil. Remove it from the tape. Make sure there's no solder on the sides of the chip. I've had that happen where some solder gets in on the sides and then bridges later. Alright, so I've cleared the solder off the sides of the chip, and now with the chip completely reballed, as you can see right there, now what we need to do is just do one final heating with no stencil to make sure all the balls are fully seated. Alright, so that looks really good right there. So let me go ahead and show you a close-up here. Yeah, there we go. As you can see, all the balls look completely uniform. They no longer look bad like they did before, where some of them were not fully attached to the pads or missing completely. So we are now ready to begin the process of soldering this, as well as the 4 NAND chips, onto the SSD PCB. Alright, so as you can see, I've got the board and the board preheater now, and to begin this process, the first thing I want to do is just install the LED, as I mentioned I was going to do once I got the board on the preheater. So in order to do that, I'm just going to get the LED out here onto the preheater, and then I'm just going to take it, apply it with a pair of tweezers, and solder it on just like all the other SMD components. Alright, so as you can see, the LED is now on. I have verified that it is indeed in the correct orientation. So now what I'm going to do is just shift the hot air or the board preheater over to heat right below the SM2236 chipset, and now we'll just go ahead and solder that on. So to do that, I'm just going to apply some flux, just a tiny bit there. And then we'll take our newly reballed chip, align it appropriately, and then of course solder it on. Alright, so the SM2236 has now been fully soldered. So now we're just going to take each of the 4 NAND chips, place them onto their pads, and then solder them on as well. Before I do that, I want to clean a little bit of this old flux off here. There we go. And then we'll just apply some new flux to each pad. And then solder the chips on. Alright, so that's all 4 chips successfully soldered on. So now I'm just going to turn off the hot air in the board preheater and let everything cool down. And then we can begin the process of soldering on the connector. Alright, so as you can see here, I've kind of got the board propped up vertically here in the vise. And that is because, of course, I have to set the connector or the pin header down onto it and then get it held in place by a piece of solder on one of the pins. So in order to do that, I've already actually removed the one pin right here, which lines up with a no connect pin. And that, of course, is the key for the IDE connector. So that pin does have to be removed. And once that's removed, we can just align it like so. And that pin that is supposed to be removed is right there, as you can see. And then I'm just going to take my soldering iron. Let me actually get this all propped up so it's pretty even. This is kind of a pain to get started, but once it's on by one pin, it's actually pretty straightforward. And actually, I forgot, the first thing I need to do is apply some fresh flux to these. Just like that. And now we can take our connector and slide it on. Alright, so that's pretty well aligned there. So now I'm just going to start by applying a little bit of solder onto the tip of my iron. And I've got a decent blob on it there, as you can see. So now I'm going to try to hold it as still as I can using a pair of tweezers. And then just apply the solder to one of the pins. There we go, so I got that one applied successfully. And now, of course, we need our little 4-pin section here for the jumper. And this, like I mentioned, allows you to select between master, slave, and cable select. So we'll get that on as well. Try to get it as straight as I possibly can. And that looks pretty good right there. So now that those are both tacked in place, we can just set the board back down onto a flat surface like we had it before, and then proceed with soldering the remainder of the pins. Alright, so as you can see, I've gotten the board back on a flat surface here, and now we can just go through each pin and solder it to its respective pad. Alright, so as you can see there, the connector has been fully soldered into position. So the last thing we need to do is apply a jumper to set it to be master, and then we can connect it to the computer, test it, and see if it actually works. So let me go ahead and get a jumper out here. And we'll take it and put it on the outer 2 pins. Just like so. And that will set the controller to be master. So now I'm going to go ahead and connect it to my computer, test it, and see if it actually works. Alright, so as you can see here, I've got the newly assembled drive connected to this 2.5-inch to 3.5-inch IDE adapter right here, and then that adapter is connected over here to this 3.5-inch IDE to USB adapter. So I've also got that connected to a power supply because as you can see, this requires a 12-volt input because it is of course designed for a 3.5-inch hard disk. So with that, I'm going to go ahead and turn the power supply on and see if the computer detects the drive. So let's go ahead and turn it on here. And as you can hear, the computer did detect the drive. And now that the computer has detected the drive, the next thing we need to do is program the controller for the NANDs we have installed. So in order to do that, you'll need the Silicon Motion SM2236 MP tool or mass production tool here. So I'll go ahead and just open that here. And once the tool is open, we're just going to go ahead and select Scan Drive. And as you can see there, it detects the SSD we just finished assembling there. And the next thing we want to check is to make sure all 4 NAND chips are being detected. So in order to do that, I'm just going to click right here. And we want to make sure there is a CE or 4 CE IDs detected. So it detects the ID of the chip on 4 chip enable lines for each of the 4 chips. So you can see channel A has all 4 CEs with a chip detected. So does B, C, and D. So that is a very good sign. That means all the chips are wired to the controller correctly. So now what we need to do is go to the parameter tab and select the correct flash that we have installed. So in order to do that, we need to select Edit Config up here, type this password, which is 320, not sure the point of that, and then we want to select the NAND chips we have here. So we select Auto, and you'll see it'll locate some flash chips based on the ID of the flash chips that we just looked at. So now we need to figure out which chips we have. So I know that I got 512 gigabit chips, 4 of which will give us a total of 256 gigabytes on the drive itself. So you can see PF29F64B08 in CMF2. We just want to make sure that that matches up with the part number on the chips themselves. So yeah, you can read it right there. 29F64B08 in CMF2. So we want to make sure we select that CMF2 right there. Perfect. So now the correct flash chips have been selected. We can select Save Config and go over to the Test tab. We'll go ahead and select Scan Drive one more time just to make sure everything is still good. And it is. And now we're ready to program the drive. So let's select Start. So it does do a pre-test of the flash chips installed. And as you can see, the programming was successful. So now it reads the capacity of 241,000 some odd megabytes there, which should be about 256 gigs or so. So now let's go ahead and close out of this, turn the drive off, turn the drive back on, and make sure it is detected properly. So let's go into disk management here. And as you can see, it detects a uninitialized disk, so we'll just format it with GPT. And yeah, as you can see, there is our SSD detected and working. So now what I'm going to do is I'm going to go ahead and install this drive into a machine after getting it all cleaned and such with the ultrasonic cleaner, and then we'll give it a complete test, install an operating system on it, and make sure it works in that regard. So with that, I'm going to go ahead and get this drive all cleaned, and then we'll begin the final test. Alright, so as you can see here, I have finished ultrasonic cleaning the board, and as you can see, all of the flux has been fully removed. So now the board is nice and clean. So with that, I've gotten this G4 Mac Mini taken apart here. As you can see, I have gotten the original hard drive removed. So now what we'll do is we'll just go ahead and install the SSD into the machine and see how it works. We'll just take the thing here, and it does go upside down in there, so we'll just go ahead and plug it in. So there we go, we got the SSD now installed. So now I'll just go ahead and put the machine back together, turn it on, and we'll give it a test. Alright, so as you can see here, I've gotten the Mac Mini booted into a copy of Tiger, and that's actually running off this PowerBook G4 here in target disk mode. You can see I have it connected to the FireWire port there. So as you can see, it detects a uninitialized drive. So we'll go ahead and get rid of this. We'll go ahead and select Initialize here. And then, in theory, Disk Utility should detect the drive. So there it is. You can see the drive is detected with the name we gave it in that software, the MP tool. So now let's go ahead and go to the Partition tab. Select one partition. Make sure it's set to Apple Partition Map. Name it SSD and select Partition. You can actually see the LED in there that's on the SSD that you saw earlier while we had it plugged into the other computer. But yeah, as you can see, it formatted the drive successfully. It's shown up here, and it has the expected amount of space available. So what I'm going to do now is I'm going to copy this install of Tiger onto the SSD, and then that way we can boot from it and give it a performance test and see how it runs. So I'm going to go ahead and get that done, and then resume the video once Tiger is copied to the SSD. Alright, I have just finished copying the installation of Tiger onto the SSD, and as you can see, it is booting and working perfectly. So let's go ahead into About This Mac here, go to More Info, and we'll go to ATA, and you can see the drive appears as intended right there. So you can see all its information there. You can see the stuff that we programmed on the MP tool once again, and of course the single partition with macOS on it. So with that, the last thing I'm going to do here is open up Xbench, and we're going to go ahead and just run the disk test and see what the speed of the disk actually is in this machine. Alright, so as you can see there, the results are, or the test has completed successfully. So you can see the maximum speed we got there is the uncached read at the very bottom of that top sequential section there, and that was about 87.71 megabytes per second. And then on the random section we got up to 65.11 megabytes per second in that test. So the performance is pretty decent. I don't know what the IDE bus in this supports, but this drive should, with this controller, should support up to UDMA 6 or ATA 133. So yeah, that has been the completed assembly and test of my custom 2.5-inch IDE SSD. Now, one thing I want to mention is this IDE SSD and the design and everything will be completely open source and be put on a repo in my GitHub account. So I will put a link to that in the video description. And I also do plan to sell these drives. Of course, I also have 100 boards I need to assemble to sell, but I do intend to sell them if anyone is interested in buying them. Likewise, there will be a link in the description for that as well. So with that, I hope you enjoyed this video.